Okay, guys. I hope you can hear me very well. Today's experiment is about the stoichiometry here of potassium. We'll have a mixture here. I hope the spelling is correct, but stoichiometry of mixture of potassium chlorate and potassium chloride. So what we want to reach today, we want to reach this mixture here. How many percentage of potassium chlorate is? We don't know how much is it, and we don't know how is the other mixture part is how much is the yield percentage. So we have to come up with this one here. So this is the purpose of this experiment. Okay, in order to do this, we set up an experiment today, and you can see this experiment here. Everybody has this? Everybody has this? Okay, so let's take this one out. You can take a snapshot, whatever you can. I mean, you can listen to me or take snapshot, whatever you want. Can I take this one out? Okay, now, with this in mind, what we will do here, we'll take this mixture here, and we'll start heating it and decomposing. So we'll use decomposition reaction. We'll take the advantage on this, the chlorate and the potassium, the decomposition here. This is greater than 800 to melt. That's a melting point. This is less than 800. That's melting point. Okay, so therefore the Bunsen burner, our Bunsen burner is about how many degrees? Bunsen, say the flame here. So how much our flame here in the hood? How much is it? What do you think the flame from Bunsen burner? How much? 500 degrees. And the gas, your methane gas, when you burn, that's about 500. If you have a salt, potassium chloride or sodium chloride, it's not melting. The salt inside your food is not melting, because you need higher temperature than 500 degrees to melt potassium chloride or 600, about between 600, maybe 600 something to 800. So it's not. So we'll take the advantage on this, and this chlorate is coming and decomposing at lower temperature. We'll take this here, and can I take this one out? Okay, so I'll take advantage of this and say, well, I have the perchlorate here. I'll decompose this one here to potassium chloride and oxygen. So this is decomposition, and the reaction is very slow. So I have to help it at adding manganese oxide. This is a catalyst. Has nothing to do with what? With the reaction. It's not part of the reaction, but it speeds up the decomposition reaction. So MnO speeds up the rate of the reaction, and this is what we call it catalyst. Has nothing to do with the with the actual reaction. So we use manganese oxide, and we have potassium chloride and oxygen. Now, because we are dealing with stoichio means stoichio here means mole calculation. Mole calculation. We are dealing with mole calculation, and metry is measurement. So we are dealing with mole calculations, and we have this here. This decomposition is not balanced. This equation here, as I said, don't worry about don't balance the catalyst. The catalyst is not part of the reaction. It speeds up the reaction. So how we can balance it? Well, this one is 3, correct? And this one is 2. Potassium is balanced. Chlorine is balanced. But however, oxygen is not. So in order to get odd, even, odd, so I will take the 3 here, put the 3 here. Again, balancing chemical equation does not have any what? Does not have any rules. Trial and error. So I put 3 here, then I have 6. How about putting 2 here? So I have the oxygen straighten up, but then I destroyed the balancing of potassium and the chlorine atoms. So I put here 2 and 2. Now it's balanced. So what's the mole coefficient we have here? Mole coefficients. Somebody still remembering from the lecture? This is 2. Okay. This is 2. And this is what? 3. Mole coefficient or mole ratio or coefficient ratio. Mole ratio or coefficient ratio is 2 to 2 to 3. Correct? 2 to 2 to 3. So now, after the decomposition, correct, I can what? I can work it out and see how much oxygen is what? How much? I start with the sample. The sample is 2 grams, correct? Don't worry about the amount of manganese oxide. Manganese oxide about 0.5 grams, correct? I use what? We'll come back and look at this, 0.5 grams. This here is 2.0 grams. So I decompose this, and then I get what? Amount of what? Of my oxygen coming out in grams. So I can go back and then calculate how much is potassium chloride, how much is this in grams left out of this decomposition, how much of the chloride came as a product there from the decomposition. With knowing this, then I can tell whatever grams I came out from the oxygen, whatever came out from potassium chloride, divide them by the whole number I started with, multiply by 100, give me what? The percentage. So let me just show you here an example, and then we'll start with the experiment. So can I take this one out? Everybody has it? Everybody has it? Okay, so let me take this one out, and then let's start with the looking at the example here of the calculation here, so you can see it. Here in this, that's the calculations here. So we the example here, we'll be taking what? We're taking 2 grams. But here they after whatever they got is 0.7 grams after heating, decomposing, heating the sample, correct? And the mass of oxygen release is 0.950. So this is what they started out. If you look at the whole thing, they start with this amount here, but in our example we start with what? 2.0 grams. But they started with this amount, correct? After heating, whatever residue came out, the residue is came out to be this. The residue is KCl plus leftover of chlorate, correct? This is the residue here, both of them. So now we'll take the whatever is given, the minus those things together, whatever you started with, minus the residue here, will give you what? Amount of oxygen released, correct? Whatever is missing is what? Oxygen. We have to decompose this, the mixture here of potassium chlorate with potassium chloride to get rid of oxygen and then calculate the oxygen. So we have here oxygen. This is the amount of oxygen can be used to calculate the flow rate. 0.25 grams. Here you divide by molar mass. Molar mass divide molar mass of oxygen. This one from the equation. Remember the equation we did 2 KClO3 will give us 2 KCl plus 3 O2, correct? So we have 2 of this to 3 of this. So I put the 3 mole of oxygen underneath because I want to cancel mole units of mole oxygen, correct? So the gram of oxygen is this atomic smaller mass of oxygen with the grams of oxygen. Then this is the molar mass here, multiply with potassium chlorate molar mass. Correct, guys? And this one here from chemical equation, So with this in mind, I got what? My grams of what? KClO3. Now if I have this one here, I can get the whole, what I started with, minus KCl3, that's the whole mixture. That's the whole starting mixture, correct? And that's what I get of KCl3. So whatever left here is what now? KCl. Now I have to calculate what? The percentage on each of those components in the mixture. This is why I started out. So the mass percentage is the whole, this is starting material here, the starting amount, and this is the recovered one. This is recovered one. So those are, we call them recovered after the experiment. Recovered divided by the starting amount you started, multiplied by 100, that will give you the mass percentage. So the mass percentage of perchlorate, we calculated from the oxygen released, is this one here, 0.638, divided by the starting material is this, you get 67.2. And then the potassium chloride, we subtracting from the whole, came out this, divided by starting, multiply by 100, give you this. Okay, guys? That's the simple calculation today. And even that, I gave you can I take this one out? Can I take this one out, guys? Okay, so, any question about this? Let's go for the experiment. Before we go to experiment, just show you that I did modify this. The lab supervisor did not do that, but I said it's better to show the students how to do the steps. Okay, guys? Look at the steps here. Step 1, they give you all the way you started with the test tube, correct? Mass empty of the test tube. This mass of that, this is after the heating. I should have done this one here after the heating. So we have after heating. And you can go at very easy steps. All the steps are here. All the steps you can here. I did that, I showed him. He said that's easy for the students. Let them do that without. But he sent the whole thing, he had resent the whole thing without those steps. But I think it's better to show the students those steps, they can follow the calculation there. Okay, guys? So now, any questions so far? Any questions so far, guys? Any questions so far? Any question? If you don't have any question, then we'll go and look at the experiment itself. So, the experiment itself is straightforward. You can see the experiment is straightforward. So you will have a stand, correct? You will work in the hood, and today you have to keep your goggles all the way on your eyes, because you are heating what? You are heating particles, and there is possibility that the test tube will break, and then all the particles will come to your eyes. So make sure when you heat, put the window of the hood down, and you have to have your goggles. Even though the window is down, you have to have your goggles on. So you will put the test tube here with 45 degrees, and this is just clamp to clamp the whole thing. And here is our Bunsen burner. So here's the flame, and here is 45 degrees tilted test tube. So first thing is, here, listen guys, I have fingerprintings, I have moisture inside this tube, a lot of impurities. I have to heat this one here first. What I have to do, heat for 5 minutes. Then you cool it down. Okay? After cooling it down, you have to wait. This is empty test tube. Now weighing it, you cannot weigh it while the whole thing is filled with your mixture, correct? So you have to use, when you weigh this test tube, weigh it with the smallest beaker in your drawer. So smallest beaker in your drawer. So you keep this one here upright or straight. Upright or straight. The test tube has to be held inside the beaker because you cannot keep it flat. You have mixture. The mixture will go out on the balance. You will destroy the balance. You have to clean the balance then after that. And so after you are done cooling, after heating, from now on you will never touch the test tube with your hands or with your fingers. So use the tissues. Use tissues to touch this one here. Whenever you want to get it out, put your right hand, if you are right-handed, the bottom of the test tube, and clamp it with the left, or vice versa. If you're left-handed, then you hold it to the left, the bottom, and then unclamp with the right hand. Okay, guys? Never touch the whole thing, because all this step will be gone. It's no use for it. We are using this step to get all the fingerprinting, all the impurities out of the test tube, because this is very sensitive for any impurities. If you have too many impurities or too much of junk, then your data will be off. Correct? So now I have the weight with the beaker. Weigh all the time with the beaker, because you have to have the test tube straightened up, otherwise it flip if that does not have a beaker just to help it. So now we have this. Now I'm ready to add this here, a black catalyst. After weighing it with the beaker empty, correct? Then I have manganese oxide. It's a black precipitate or black solid. I heat this one here for 5 minutes.
And that's 0.5 grams.
Heat. This is 0.5 grams. Yes, 0.5 grams. In the movie you will see, in the video you can see of the lab supervisor. He made this and he asked me to come and supervise the whole thing, and if it's okay, then he will give it to the other professors. It's okay. It's running, but I'll tell you some areas out of recording, so you'll not be offended or something. I have some ideas a little bit to change a little bit what is a little bit of modification, but they will be off recording. So 0.5 gram of manganese oxide, heated for 5 minutes, then cool down and reweigh. Why we are doing this? Well, manganese, the black precipitate, has what? Moisture, correct? Has moisture inside. It's not dry 100%. So we have to get all the moisture out, and we have to make sure that really we have a 0.5 gram just pure catalyst. This is our catalyst. Speed up the reaction. Has nothing to do with the reaction. It's not part of the reaction. Okay, guys? After cooling down the whole thing, after 5 minutes, cool down and reweigh. Always cooling down, minimum is 5 minutes. We did this one here yesterday I think, and the students are taking this one here and then wait while hot. You are destroying the what? First of all, you have bouncy effect. Your mass is not correct. Second, you are destroying the balance. You don't put hot stuff on the balance. Make sure that's minimum 5 minutes. So 5 to 7 minutes, it's cool. You can always touch it with what tissues, not with your fingers. Okay, guys. So 5 minutes, and then it's cooled down. Now you take it out with your hand. Now you'll add to it. In here, you add the mixture. The mixture is add the mixture here after cooling, weighing, which is 2 grams. The mixture is potassium chlorate plus potassium chloride. Okay, that's the mixture here. So, and you can tell even from my colors, this is a heterogeneous mixture. This is what? A heterogeneous mixture, because manganese oxide particles is bigger than the powdery potassium chlorate and potassium chloride. They are very powder, but manganese oxide, they have highly large particles. So it's heterogeneous mixture, even from my drawing. And then you'll tap this one here to make sure that the mixture is really looking grayish black, because the black is large particles will cover the small powder of the mixture. The mixture is very powdery here, correct? And then after that, you will heat for 15 minutes. Okay, guys, 15 minutes. And then you will come with your see how much is your weighing came out. If you feel that the weighing is first weighing after 15 minutes, then you'll put it back in. You record the whole thing, correct? Cool it down, 15 minutes heat, cool and weigh. Cool, let me write it here. Cool and weigh the whole thing. 15 minutes will take care of all the bubble. This is bubble of oxygen here. Oxygen will come out. You have to make sure oxygen is out. Then you will wait another 9 minutes. You heat it another 9 minutes heating, or I'll say reheating. So the first heating is 15 minutes. This is first heating, correct? And cool it and get to the amount of the residue coming out, and then after 9 minutes, that will be your second heating. There is no need for the third heating unless you are seeing that there difference in the weighing, the first weighing and the second weighing, they are huge, far off. Then you will do the third weighing until you get those within half a gram difference. Okay, guys? And then you are done. Then you do your calculation. That's all. So, any question about this? Can I take this one out? Take it out. Everybody has it? Okay. Let's now go to the okay, guys, just hold on. Just bear with me a little bit, and we are going to the experiment here, and I will leave you with this one here.
So this can take you overnight.
Yeah, I know. So I'm just recording with our experiment for today. It's doing the experiment for stoichiometry. We prepare our this one is better for that one. We prepare our test tube, Bunsen burner, and we weigh our mixture of potassium chloride and potassium chloride together, and we use the catalyst as manganese dioxide. First of all, we need to make sure that
That's our lab supervisor. He's in charge of all the labs here, Clarkston Campus.
Just trying to test our, just trying to warm our test tube for only 1
I was
minute
helping
or
with
2
the
minutes to
recording.
make sure that
I was
there's
helping
no
with the recording.
heat will, there's no humidity will be inside the test. So we will put the flame at the bottom of the test tube, just to make sure that
You start test tube empty, test tube empty to get all the fingerprints out and all impurities out. Don't put anything inside, empty.
Of the lamp. So I think there's smoke there. Let me check, we are good. Turn off the Bunsen burner. Okay, and wait until we test tube cool down. We use this phone to hold the test tube, and we have to take the weight of the test tube by using the small beaker. Okay, we're using the
I will make some modification. I will let you know after the recording is done. I want it to be off
small
recording.
beaker.
Some modifications, small
Put the
kind
test
of
tube inside the beaker. Try to take the mass of the test tube, empty test tube after it's cooled down. Make sure that you have to put the beaker on the balance and start the balance. Check the mass of your.
The smallest beaker helps to
So
keep
I'll
the
put the
test
beaker
tubes
around.
straighten up,
And then I will,
not tilting or
test tube
falling
inside the beaker
on the
and try to
balance.
take the mass of the beaker without any materials. Okay. Now all the yoga. Moving the arm, release the gland of the head. Put the test tubes inside the beaker, like this. Okay. Make sure your test tube is a little bit full. Take the mass of the empty test tube.
Yeah.
Put the test tube in a beaker, right? The smallest beaker?
Yeah.
Is that weighed prior to heating and then
No. You weigh them both at the same time.
once that
Empty, when it cools down.
Yes.
Both. Yeah, weigh the beaker
Then we
and the
put,
test tube. Both.
1 gram, we weighted 1 gram.
And use the weighing, they call it weighing dish or weighing both, weighing dish
Side,
to weigh the material you have. So he wants to show me the experiment. He did double,
weighted 1 gram.
1 gram, but in the procedure half a gram to show me the whole thing proceed faster. So he used half of the time.
Then you weigh the beaker, the test tube where the manganese dioxide.
It's a very nice hoods. Those are the organic. They are much, it's brand new ones. Nobody have used those hoods in the organic yet. Because they use micro glass equipment, so small, tiny. The hoods are very clean. Ours is not clean because we are working on the hoods.
I am going to hold the test tube by using the glass.
Again, this demo is for me. This demo was taught for me, not the students, not the other professors.
Make sure
But I took his permission to show just my students.
Right in the test tube. And the most important thing, you need to make sure that your test tube sitting in angle, like this way. Now we need to
How many minutes? 5 minutes. That's the
manganese
catalyst.
oxide.
No mixture inside. That's the
For a
catalyst.
certain
5
time.
minutes only.
Let's take about 5 minutes. Spark the Bunsen burner. Make sure your burner with the blue flame. Then put it like this. Try to put the top of the flame at the bottom of the test tube.
Yeah, this situation
Try
I
to
have some
heat up
modification.
the-
I will let you know.
Manganese dioxide for
Off
5
record.
minutes.
Will not hold it up.
Then
Will not touch the flame
after 5 minutes,
condenser at all. Keep it in one.
cool down also
in one
for
position.
3 minutes.
Thus, he has a PhD. He knows what he's doing. I'm not allowing my
Flame
students
will
to
be at
play
the
with this.
bottom of the
They
test.
might burn themselves or somebody else.
You said the beaker might,
What's that?
the beaker might, I mean, the test tube might crack or
Now, if you overheat, anything will crack, even at home. If you cook in any glassware, even heat resistant and with too much heat, it will crack. Yeah, it will crack. I make my tea in a kettle made of glass, but I'm watching it. My friend told me he explode his at home because he forgot to overheat it, the whole thing and the tea all over the stove. So no, anytime you overheat,
I hope we'll
Yeah.
finish this demo within 30 to 45 minutes without any issue.
no, just 5 minutes, guys. 5 minutes. Heating 5 minutes. What's the purpose of heating? To get the moisture out of manganese oxide.
Make sure all the
Manganese oxide is wet.
test tube or the
The
side
air
of the
here.
test tube will be
5 minutes will be enough to drive all the
And
moisture, H2O. So we make sure that it's really dry. Yeah, I'm not letting the student do this, playing with the flame Bunsen burner. He has a PhD, he knows
I
what
think
he's
your
doing.
flame is too
But
high.
students are not allowed to do that.
Use the
It's too risky.
flow of the gas.
I mean, I did it on my research, I did that, but we know what we are doing, so we have more experience, too many years.
Make sure you can control
But
the height
not
of
the
the
students.
flame. put for 1 minute, just to make sure that all the utensils will be warm enough. And we'll bring in the dioxide to be dry without any moisture. Okay.
And anytime you want to keep the test tube cooling inside the clamp, don't take it out to cool it out. Keep it there cooled for whatever time you want to cool it, 5 minutes, 6 minutes, 7
Now,
minutes.
shut off the
Inside the clamp.
Wait for 3 to 4 minutes, cool down the test tube, and raise the test tube again after cooling down.
It's cooled down inside the clamp, not out. I have yesterday students are breaking a lot of those test tubes because they take them very hot and the beaker's cold and then the whole thing is just burst. The whole thing is broken. No, keep it there. When it's 5-6 minutes, then it will be enough. Take it and it's secure and not at different of temperature. The beakers at bench temperature is around 15 degrees Celsius and this is about 500 degrees. That's a huge difference. Keep it inside, let it cool inside like this. Inside the clamp. And then after 5-6 minutes, you can touch it with the tissue. If it is good, you go away. But don't take it when it's hot. Yeah, you can just give it another 1 minute or 2 after 5 minutes. Yeah, will not take. And whenever you are taking the test tube, you have to turn the Bunsen burner, the flame out. Because if the flame is on and you have your hand in to grab, there's a possibility you will burn your jacket or whatever your clothing and your skin. So anytime you have to take in and out the test tube, you have to turn the gas off. The Bunsen burner off. Yeah.
Use the tongue to hold it like this way and put it inside the beaker. Use it to cool down for 2 minutes, and 2 minutes, just make sure it's cold before you have to go to the way your test tube when you're then getting dioxide. I'm trying to put the put your measurement to the whole distance.
So he did not wait. So he took it out 5 minutes, but now it is thinking it's still warm. So keep it in the beaker now, because you don't take it for a while hot inside the beaker. It will crack. The temperature difference is huge. So keep it for 1 minute, and then you can, while it's cooling inside, you can go and weigh your mixture, the 2 grams. You can go and weigh your mixture 2 grams.
Okay, so take your beaker with your test tube.
See that? We'll not touch it with your finger. We'll touch it with tissues. Tissues, because then you have the fingerprinting and impurities from your finger. Always with the tissues. Now, he has to weigh what? The manganese oxide, the dry one, without any moisture inside. And then we'll weigh the mixture 2 grams. Put the mixture inside the manganese oxide, the catalyst.
Now we need to add all the 4 grams of the new mixture, potassium chlorate with potassium chloride. Add all your 4 grams of the mixture inside the test tube like this.
That's the mixture here, 2 grams.
Make sure to
He put 4 grams to speed up the reaction.
mixture inside the test tube.
Yeah, use the weighing dishes. Yeah, this called weighing dishes, or sometimes they looked like a boat in the old times. They called them weighing boats, but now we call them
When you
weighing dishes.
have your oil mixture inside the test tube, try to tap the bottom of the
That's
test
another
tube by
modification. We're not tap it with a finger, fingerprinting. So we tap it with a pencil or with the spatula. Hold the whole thing with the tissue, and then tap it with the spatula. Not with your fingerprint.
Like this.
He wants to show me, but that's will give an error. Because we
Mixed in the
at the
right
beginning
way.
I heated the whole thing to clean up and get all the fingerprinting out. Now if you tap it with the finger, then there's a problem. You get all the fingerprinting back again. As I said, that's more just made for me, so he did not give it to anyone. But I think all in all excellent. All in all excellent. Except the few of adding Bunsen burner and the impurities. That's the issue here.
To decompose your mixture, potassium chloride with
How many minutes we have now with the mixture?
potassium
Grayish black.
chloride.
It's grayish black. How many minutes?
Decompose,
15 minutes now.
will release.
The first heating 15. And then after cooling, go away. Then put it for another 9 minutes. Go and wait. And then look at the two weighings. First heating, second heating, and compare. Correct? And they come very close to each other. If it's not, then do the third heating.
And the one like this. That's good. I don't know if we. At the bottom of the test tube. Make sure the top of the drain will reach the bottom of your test tube. Correct?
Yeah, like this. The flame is on and he put his hand. That's too risky. That's a no-no. That's a no-no. But as I said, he knows what he's doing. And but I will not let the student do that. You will not do anything while the flame is on. Flame has to be off. Set up everything, and then you can turn the flame if everything is set up. Because that's safety problems. And that's what I do first. First, I will set up for you the whole distance, everything. And you'll never change this setup. Keep the Bunsen burner in the same. You just open the clamp to take in and out the test tube. So I will do it for you. The first step, I'll set you I'll set up the whole thing with the distance here between the flame and the test tube. So as I said, all in all, it's an excellent experiment.
We are rolling our mixture for 15 minutes to decompose the potassium chloride into potassium fluoride and oxygen gas. And after the 15 minutes, we need to cool down the test tube for 4 to 5 minutes, and then take the mass of the test tube with all of the mixture together by using our beaker, and try to light the first one after we heat up the test tube for 15 minutes. After that, we need to heat up the test tube again for another 8 minutes, and waiting as put it to cool down, and take the mass again and see the difference between the first one and the second one. If the differences between these two runs are within 0.05, that you are good. You don't need to do the third run. If it's not, you have to heat it up your test tube for the third. because of the time issue that I have, I will do only the first one and take the measurement, but you can do the second one and see the difference between these two. Again, if you have 0.5 difference percentage, that's all. If you think you got more than that, you need to do the third one. After that, you need to do your calculations. When you finish, we need to clean your test tube by using the tap water with a brush and dump any solution in the barrel as you put it in the corner or inside the room. You don't need to dump your solution inside the sink. Okay, this is for your safety and the safety of our environment. I just need to wait another 5 minutes, and then I will wait for cool down for test tube for 5 minutes, and I wait the mixture and see what is the mass, and I will stop the recording. But you need to proceed with your second and the third run if you have any differences between the first and the second.
So the first heating is 15 minutes. The second heating is 9 minutes.
The last 2 minutes, I will just try to make sure that I try to heat all the test tube from all the sides.
As I said, we'll not do this taking the Bunsen burner out. We'll keep Bunsen burner all the way to the end of the lab, localized in the same position. We'll not move it anywhere. It's just too risky.
Test tube, make sure that we heat up our mixture in the proper way, and then I will shut off the flame and leave it to cool down, and I will stop the recording. Shut off the valve, the gas off, and leave it to cool down for 5 minutes. And then take the mass of the test tube with the speaker and put your measurement in your lab notebook, and then go proceed to the second one. Doing the same thing, but for the test tube, clamp it again on the clamp and heat it up for another 8 minutes, and even if you go down, take the difference between the first and the second one, and you suppose you got the difference between two measurements within 0.05. Okay, so thank you very much for your listening.